Hey guys, so welcome back. We're going to get started on lesson 9.3, day 1. Our goals today are to talk about sines, quadrantal angles, and reference angles. Alright, so up here I got us started. We're going to talk about the ratios that we're going to be using when considering any angle in standard position. Okay, so you can see here that I drew an angle in standard position. Theta is in standard position because its initial side is locked and its terminal side is the one that moved. And then I dropped in the height and I formed a right triangle. And I labeled the triangle X, Y, and R. R because it's the radius of the circle. X is along the x-axis and Y is the vertical axis of or vertical side of your triangle. All right, so what I want to do is I want to replace opposite hypotenuse, adjacent hypotenuse, opposite adjacent with the variables x, y, and r. Okay, so here's theta, the opposite is y, the hypotenuse is r. So sine of theta, from now on, we're going to talk a bit about it as y over r. Cosine of theta is adjacent over hypotenuse, so that's going to be x over r. And then tan of theta is opposite over adjacent, so that's y over x. All right. If you know these three, then the reciprocals, you just flip them. Cosecant is going to be r over y. Secant is r over x. And cotangent is x over y. Right. Now, keep in mind we have a right triangle here, so we could set up Pythagorean theorem, x squared plus y squared equals r squared. If I wanted to solve for the radius, I could square root the entire, or both sides of the equation, and I'm going to be left with r is equal to the square root of x squared plus y squared. Okay. Okay, so let me erase and get us set up for the first example problem for today related to this information. So our first example says, let 8, negative 6 be a point on the terminal side of an angle theta in standard position evaluate the 6 trig functions of theta. Evaluate the 6 trig functions of theta. Okay, so I'm going to first draw a diagram to get us started. All right, so here I have my y-axis and my x-axis. And then I have this point 8, negative 6. So I go to the right 8, 1, 2, 3, 4, 5, 6, 7, 8, and then down 6. And I put a point. All right, it says that this angle is in standard position. So that means that its initial side is locked to the positive x-axis. And its terminal side is the one that moves, and it goes through that point because it says that that point is on the terminal side. Okay? So theta, I'm going to put theta right here. So theta is formed by the terminal side and the initial side of your angle. Okay? And then what I'm going to do is I'm going to drop in a vertical segment to that point so that I can form a right triangle. Okay. Now, for your right triangle, this is going to be well, actually, this side of the right triangle is how many units long? It's 8 units long. This side of the triangle is how many units long? Well, we went down to 6. And I'm not going to write -6. I could write -6. Maybe I will write -6 since I went down 6. Even though it's the side length of a triangle, all right, because we're in the fourth quadrant, I'll put it as a -6. And then finally, we need to figure out the radius, the r value. So using Pythagorean theorem, 8 squared plus -6 squared equals r squared. So I have 64 plus 36 equals r squared. 100 equals r squared. So r equals 10. So now I know my x, and they're given here as well, x and y, right? My x is 8, my y is -6, and my r is 10. That is all the information I need in order to evaluate the 6 trig functions of theta. All right, so I have sine of theta, cosine of theta, and tan of theta. Now remember, instead of opposite over hypotenuse, I want you to start thinking about sine in terms of y over r. But if you forget, you could come and think of it as opposite, right? The opposite side over the hypotenuse. So it is 6 over 10. But I want you to start trying to think of it in terms of y over r. So y over r, this is x over r, all right? So we'll get started with those two. So y over r is going to be -6 over 10. X over r is going to be 8 over 10. All right, and then for tangent, remember tangent, SOHCAHTOA, tangent is going to be opposite over adjacent, but we're going to think of it in terms of y over x. So that's going to be -6 over 8. Now, every one of those single fractions can be simplified, so we'll do that next. -6 over 10, both divisible by 2, so it's -3 over 5. And then 8 over 10, both divisible by 2, so 4 over 5. And then, yes, these, excuse me, and then both divisible by 2 again, so -3 over 4. Now, those are 3 of the 6. I need the reciprocals, right? So this is going to be cosecant, which is just the reciprocal, so I just flip it, -5 over 3. And then I'm going to have secant, which is the reciprocal of cosine, so flip it, 5 over 4. And then finally cotangent, again, reciprocal, flip it, -4 over 3. All right, and those are your 6 trig functions. All angles with the same terminal side have the same x and y, so keep that in mind. And it doesn't matter where the negative is, top or bottom or front, but not both top, bottom in this case. So what I mean by that is you're not going to have both top and bottom negative, just one is negative. You can put it in top, put it in bottom, or just right out front. So it's just little reminders. All right. Let me erase and get set up for the next part. All right. Okay, so marker. When the circle is the unit circle, it has a radius equal to 1. So, remember on the last bit of notes that we just did, where is it? Let me see. We wrote this right here. Where am I? X squared plus y squared equals r squared by using Pythagorean theorem. So based on that, I know that x squared plus y squared, if it's equal to r squared and the radius is 1 squared is just 1. All right, and sine of theta, which is y over r, okay, would be equal to y over 1, which is just equal to y. And cosine theta, which is x over r, well, if r is 1, x over 1 is just equal to x. Okay, so little facts to keep in mind. It's helpful to use unit circle when the size of the circle is not specified. All right, so we're going to do a problem related to the unit circle now. All right, so let me, oh, I have enough room to do it here. So our example, use the unit circle to evaluate the 6 trig functions of theta equals 90. Okay, so we are going to sketch a diagram for ourselves. Here's my circle. Now it talks about an angle, theta, equaling 90 degrees. So that means I have an initial side on the positive x-axis and a terminal side on the positive y. That creates that 90 degree theta they referred to. All right. Now, if we're in the unit circle and we know that the radius is equal to 1, well, this right here is a radius of the circle. It has a length of 1. And the coordinate of this point, right, if I plot a point right there, I would be moving over 1 unit and up no units because I'm staying on the positive x. And if this also, the radius is 1, right? So from the origin to this point, I'm moving 0 to the right or left and then up 1. Okay, so those are important things to keep in mind. Now, the one that I really need to focus on, I don't really need to know this one, because what I want to focus on is that terminal side. The terminal side is this side here, so that's giving me my x and my y value. Okay, so for this problem, x is going to equal 0. Y is going to equal 1, and then you were told we're in the unit circle, so the radius is automatically a 1 as well. Okay, so now we have to evaluate the 6 trig functions. We have sine of theta, which is y over r. We have cosine of theta, which is x over r. And then we have tan of theta, which is y over x. Okay, so using these values, I'm going to have 1 over 1 for sine of theta. I should have a 90 degrees there. Maybe I should go back and put 90 instead of theta. That one I forgot. And change that to sine of 90, cosine 90, and tan 90. All right, and then cosine, we're going to have 0 over 1, which is just 0. This, by the way, simplifies to 1. And then we're going to have y over x, which is 1 over 0, which is undefined. And then we have the other 3. So we have cosecant, we have cosine, or that is cosine. We have cosecant, we have secant, and cotangent. So the reciprocal of 1 over 1 is 1 over 1, which still simplifies to 1. The reciprocal of 0 over 1 is 1 over 0, which simplifies to undefined, or which is undefined, I should say. And then the reciprocal of 1 over 0 is 0 over 1, which simplifies to 0. Okay, so that's your first unit circle type of problem. All right, when an angle's terminal side lies on the axis, it is called a quadrantal angle. All right, sometimes it's helpful to find trig values with reference angles. Reference angles are in the first quadrant and are reflectively in the same position as the given angle. Okay, so that's what we're going to look at next, is reference angles. Let me erase and get started on that. Okay. So for the next example, the directions are going to simply say, find the reference angle theta for each. Okay. We have two examples. We have negative 220 degrees and we have 17 pi over 6 radians. Okay. All right. So what we're going to do is we're going to sketch these. So let's do the first one. If I sketch negative 220 degrees. Okay, so first off, the initial side is on that positive x-axis. And then the terminal side, which direction am I moving? Am I moving counterclockwise or clockwise? You'd be moving clockwise. Okay, if I rotate 90, 180, how much further do I have to go to get to 220? This is important, so think about how much further you have to go. If I'm at 180 and I want to go to 220, that's an extra 40 degrees. All right, so just approximately where would it be? Now, remember what I said. How much further did we have to go? How far away is this terminal side from the x-axis? It's 40 degrees further, right? Because we were at 180 and then we had to go another 40 degrees. The reason that's important is because when you're finding the reference angle, you're going to put this terminal side back into the first quadrant, but it needs to be the same distance away from both the x and the y. So we're 20 degrees away from the x. So when I reflect it over into the first quadrant, I still need to be 20 degrees away from the x. Okay, or no, I'm not 20. I'm sorry, I said that wrong. It's 40 degrees. We said we're 40 degrees away. So it's 40 degrees away. Okay, so that means the reference angle is a 40-degree angle. So again, a reference angle lies in the first quadrant, and it needs to be the same distance away from the x and the y axis as the terminal side lies wherever it is in the coordinate plane. Okay. Number 2 is in radians. Now, we are still becoming familiar with radians. We're probably not comfortable with radians. So one thing you can do, I prefer you try to work in radians, but one thing you can do is convert this into degrees and then do what we did over here. Okay, so if I wanted to convert this into degrees, I'd multiply by 180 over pi. I'd then be in degrees, and I could do the exact same thing I did over here. However, like I said, I want you to try to become more comfortable working in radians. So I want you to think about where this would be in our coordinate plane in radian form. So let me sketch it again. Or sketch to start. Okay, so remember we talked about a full circle being 2 pi, all right? If you divide 360 in half and you get 180, divide this in half and you get pi. Divide pi in half, you get pi over 2. Okay, so if I rotate 90 degrees, that's the same thing as rotating pi over 2 radians. If I rotate 180 degrees, that's the same thing as rotating pi radians. Okay, so that's important to know. So let's think about if I was to rotate 90 degrees, that's pi over 2. Okay, but this is 17 pi over 6. So what I like to do is I try to get it to be as close to either pi over 2 or pi as I possibly can. So I'm thinking right now that if this was, let's put this in terms of the denominator of 6. If I wanted to rewrite pi with a denominator of 6, since this has a denominator of 6, right, I'd have to multiply top and bottom by 6. So I'd have 6 pi over 6, right? If I wanted to rewrite this in terms of a denominator of 6, I'd have to multiply top and bottom by 3. So I'm going to have 3 pi over 6. If I wanted to write pi over 2 with a denominator of 6, again, I'd have to multiply top and bottom by 6. So I'm going to have 12 pi over 6. Okay. So if I rotate one full circle, that's going to be 12 pi over 6. But I want 17 pi over 6. So how many more pi over 6s do I have to go? All right, well, what's the difference between 17 and 12? 5 more, right? So you have to figure out where you would land. Well, here's another 3 pi over 6, and here's another 6 pi over 6. I don't want 6 pi over 6. I wanted 5 pi over 6. So, let me get us started. Here is my initial side. Again, if I rotate one full circle, that's going to be 12 pi over 6. And then another 3 pi over 6. So now I'm at 15 pi over 6. I want to get to 17 pi over 6. Well, I don't want to go all the way because that would be 18 pi over 6. So I'm a little less than all the way to this x-axis. So again, it's a full circle and a little bit more. Okay. So how far away am I? Remember, if I had gone all the way, that would have been 18 pi over 6. So I'm just pi over 6 away. So I'm going to flip this back into the first quadrant. And I'm pi over 6 away, because that's how far I am away over here, pi over 6. So your reference angle is pi over 6. Okay, so let's keep on. Oh, that was the last one, I think. It was the last one. Yep, that was the last problem. I thought I had more. All right, guys, so that is it for today. So jump on to the online textbook to get your homework done. I'll see you back here for the next lesson. Bye.